All right, here's the 10.5 polar area, part 2, and I'm going to show you example 2 of the equation of r equals 1 minus 2 sine. We graphed it on the, when I showed you polar graphing, I graphed to a sideways one of these. This is, remember, a limacon. It's got a little circle in there. So I have graphed so far, and you have in your notes the whole graph. I graphed just from 0 to 180. You can look at how much it covered from 0 to 180. So it went like this, spun, made this loop, and then it spun out. And it's going to continue spinning out and make the bigger. I have dots there, which I'm going to connect in just a second, but I want you to see that the first 180, it makes that loop. Now, it starts making a loop once it hits here and it ends here, and we're going to discuss that in just a second. So let me finish the graph now. Alright, so there's your full limacon, and they're going to ask us to find different areas of different parts of this. So the first question was the area of the inner loop. So we need to know when the inner loop started and when it finished. If you remember, it started early. So it started and then ended. Well, when was that? Well, the start and end of that little loop is when the radius is 0. So if you set the equation or set radius equal to 0, again, this is mathematically. This will be a much easier problem to solve. If I want to solve for theta, I get sine of theta is a half. Send over the 1 will be a -1. Do I have a -2? Now you push arc sine. You know, 1 sine a half. Well, we should know that sine hits a half at 30 degrees, pi over 6. Also 5 pi over 6, because it hits it in quadrant 1 and quadrant 2. So, and that's what those values are. So, since this starts at pi over 6, and if you had actually counted, you could have done this yourself. So when you start your calculator, actually the graph starts right here. There's 0 degrees. Okay, so you go, well, okay, here's the start. If you count your pushes, we'll always do, for the sake of argument, we're always going to do the push of pi over 24. Okay, that's the factory setting. A lot of people don't want to change it, so let's just do that, 0.13. So if you ever accidentally change yours, just go to that, type pi divided by 24, enter, and it'll give you the 0.13 something decimal. All right, so that's 7.5 degrees. You got more pushes, but you know, a little better looking graph. All right, it turns out that it would be 4 pushes just to get to that little center. Well, 4 pushes is 30 degrees, so we know it starts at 30 degrees. So the area, the formula's got that 1/2. Since we're starting at 30, we're gonna go 30 to somewhere. Our function squared. So we got to figure out when it ends. So if you've counted, you know, you have 4 pushes so far, and that's where you get the pi over 6. That's the starting number. So now how many pushes does it take to go all around? Well, we got to keep pushing this and pushing it, and you count how many pushes it's going to be. All right, so it's going to turn to be another 16 pushes. You're like, man, that's a lot of pushes. Well, you push it 8 times, you're going to get to here. Another 8 times, you're going to get back. So 16 more pushes from 4 will give me 20 pi over 24, which, as we know, is 5 pi over 6. So I'm going to go over the 2 methods again. Mathematically, you just set equals 0, and sine is a half at pi over 6 and 5 pi over 6. And again, it hits at a half, you know, if you keep adding 360, all those values, but we just need the first couple. And so now you got your 2 numbers right away. I like this way. But if you want to count, you got 4 pushes to the start, and then 16 more pushes. So the starting was at 4 pushes, and then 16 more pushes. So from 4 plus 16 is 20. And then reduce those, you get pi over 6, 5 pi over 6. All right, I've already done this in your notes. It's 0.544 as the area. All right. Now, what if they ask us for the area of the whole figure? Here's our dilemma. Do you remember I said there's a sprinkler there to find the area? So I'm going to start highlighting in here. If I were to, you know, send my sprinkler out starting at 0 to wherever the graph is, I go out to the graph. Well, remember the inner loop was made next. So now I've highlighted the inner loop. So if I go from 0 to, remember the inner loop ended at 5 pi over 6? it will find the area of that little section and that, okay? But now, if I keep going, I'm actually gonna find this area. But here's our problem. Because when it finds these ranks, do you notice how I go over the inner loop again? Because think about a sprinkler that shoots out the inner loop, but as it spins around and then it gets longer and it shoots out longer, it's going to cover that same area. You're going to water that area twice. So it gets a little confusing for people. So when you have to do the whole figure, if you did 0 to 2 pi, that will get the area of the whole figure, but what it has is this part got watered twice. It got watered that first by itself, and then when you watered the whole thing. So we actually have area of the whole figure plus an extra inner loop. So if we subtract off the inner loop, then we got the whole figure. Because since they did it twice, we might as well just get rid of one of them. So you can subtract off the 0.544. So that value, 8.881. And that's the area of the whole figure. Well, what if you want the outer loop? Okay, the outer loop is the area without that part. Well, how do you water and not water that part, or how do you find that area? Well, if we take the whole figure and then subtract off another inner loop, so again, 0 to 2 pi, 1 minus 2 sine, minus 2 inner loops. If you think about that real quick, so if we go just 0 to 2 pi, we water the whole figure but inner loop twice. You subtract off 2 inner loops, you now have everything but the inner loops, and that's what they call the outer loop. So that value, of course my computer went to freeze mode, is 8.338. Put here in red there. So that's how you guys have to do it, but it's kind of weird. It's definitely a weird one. Some people just memorize what to do. They'll go, okay, I'm gonna subtract off inner loops and stuff. Fine. I started taking it off the test because the people were just memorizing without no knowledge. But I want you to understand what's happening is you're spinning, and then your sprinkler is finding that area, then that area. Then when it keeps going and hitting this, it covers, you know, we get the whole figure eventually, but it only figured out if it covered that inner loop 2 different times, okay? So that's where those values come from and why, you know, that one's one of the more difficult ones. All right, I'll do the last example in another video.